101, 102 out. Write down what you need so we can help you on the test we're going to have next week, or the quiz. Probably quiz next week.
What day is it?
I don't know. Not Monday. That's all I can tell you. Hey, good to see you.
Good morning.
All right. So, problem number 1, psychological researchers plan to study the relationship between sleep and clinical depression, specifically wondering if less sleep can be associated with higher levels of clinical depression. Okay, so state the null and the alternative. Well, the null is less sleep, not associated with depression. The alternative, less sleep associated with depression. Pretty simple, I think. And then number 2, this is a one-tailed test. Explain how the study could be worded if we wish to conduct it to test. We could say, is less sleep associated with a change to depression? Okay, so change, if you just change less than to like a change in depression. Then number 3 says, using a one-tailed test for number 1, we set alpha to 0.08. Explain what this means in the context. If we find strong evidence that less sleep is associated with depression, there is an 8% chance that we are wrong. Okay. Oh, wait. I was on the wrong one. I looked at the wrong one. I'm sorry. Oh, wait, we're good. We're good. Okay, and then assume the p-value is 0.042. The alpha is set to 0.08. Describe the researcher decision. If your p-value is 0.042, you found strong evidence less sleep is associated with higher levels of depression. That would mean that you have an 8% chance of making a type 1 error, something like that. Okay, so remember the alpha is the type 1 error, and that just means the percent chance you have of making that error. And then which type of error is plausible in the scenario? Explain what this type of error would mean in the context. Well, this would be a type 1 error, and then it would mean that we found evidence associated with higher levels of sleep where there's an 8% chance that it is not true. Okay? Explain the consequences in the context of the question for making this type of error. We might find that sleep is a way that they think that would reduce depression when it doesn't really work. And then if alpha was set to 0.08, what would be the average setting to lower the value? So if we changed 0.08 to be a lower value, we would have less chance to make a type 1 error. Good to see you. And then alpha was set to 0.08. We're on page 101. What would be the advantage of setting the alpha higher? If we set our alpha higher, remember that alpha goes along with our confidence interval. So if we set our alpha higher, it becomes easier to reject the null. So that is page 101. All right. And then a soda drink company is changing the taste of one of its products and wants to conduct a taste test to see which tastes better to their customers, the old soda flavor or the new. So state the null. There's no difference in flavor. The alternative, there is a flavor difference between the new and the old. Why is this two-tailed? Well, it's,
Could be better than something.
yeah, it could be better, it could be worse, right? Yeah, that's totally it. I like it.
But which one's healthier? That's also a...
Soda's always healthy for you. Something that tastes that good can't be unhealthy. So,
Sushi unhealthy then?
huh?
Sushi unhealthy then?
Sushi?
Yeah.
I don't know. Do you like sushi?
Yeah.
It can be unhealthy then.
Real. I love the way you write that.
All right. Assume that the study considered statistically significant at the 0.10 level. Explain what this means. All right. So we reject the null when the alpha is 0.10 because we want the alpha to Yeah, we reject null when alpha is 0.10 because that's 90% confidence interval, things like that. What are plausible values of p? We could have values of p that go between 0 and 0.10. And then what is probability of making type 1 error? 10%, because 0.1 is 10%. Bless you. What is probability that we make a type 2 error in the study? Just put, for now, not sure. It could be a 0%, but I don't know. And then explain the consequence of making each type of error. Type 1, we promote a brand of soda that we think tastes better, but it really doesn't. Type 2 error, we miss the opportunity to promote a better tasting soda. And which one is worse? Or the researcher decides to make a type 2 error is worse, should be avoided. Should alpha be set higher or lower? Explain. Alpha should be set higher because alpha is the bigger chance that you get a type 1 error, so type 2 is better. And that's all I have. I'm done. I'm going to go home. All right. I am on page 3-4. Are you with me on page 3-4? So, kind of interesting. Growing up in Arizona, they actually used to do something called the Pepsi Challenge. And we really didn't care who tasted better, Pepsi or Coke. It didn't matter. It was Arizona, so you didn't really drink soda in the summertime in Arizona because it is hot and CO2 in your system doesn't make you feel good. Okay, so so you'll find when you're in Tucson, you drink soda in the wintertime and you don't drink it in the summer.
What if not at all?
Oh, I wouldn't avoid soda. Soda's good. Soda's yummy.
I didn't hear full last night.
Oh, those are good. A&W.
No, I was like, I don't even know what the beer was. It was like in the really nice little like bottle thing.
Yeah, where do you get it?
My basement, my dad has a bunch of. He loves root beer floats.
I like root beer floats too.
What's your favorite kind of ice cream?
I was trying to get
vanilla.
one.
I've asked for
That's
this.
like-
You gotta go vanilla ice cream on root beer float.
Well, yes, but like in a bowl.
That's my goal level. I want some stronger.
Bowl of ice cream. Someone said I had a bowl of ice cream, my choice of flavor.
I gotta go on a hurry.
Maybe butter brickle. No, but anyhow, this Pepsi Challenge back in Arizona, they used to have, outside of supermarkets, they would have people from Pepsi, and they would have a bottle of Pepsi sitting out front and a bottle of Coke sitting out, and they would give you a cup of each to try and see which one was your favorite flavor. But they actually found what they were doing is they would give you warm Coca-Cola. They'd give you warm Coca-Cola, and they would give you cold Pepsi. Biased or not. I mean, warm soda is not that good. Colder the better. You want it to be refreshing, right? So, kind of funny. Statistical, this is on page 34. So, we're doing statistical significance. So, let's say they find the average price of a water bill in Denver is $55. So, our null, we could say, is not equal to 55. And they have it equal to. I think they made a misprint. And then we say lower than 55. Okay, we could go with this. Now, the big thing is, could this be an equal sign? And I think we could get away with that as well. So they do have that listed. So if we were to create ourselves, and they do have a misprint, they say the standard deviation is $8. So plus or minus 8 would be our standard deviation. So if we were to draw our normal distribution, it would basically look like this: 55, 63, 71, 79. Look at that wonderful normal curve. 47, 39, and 31. Okay, there's our normal distribution based on that. Okay, so if the null hypothesis is true, we'd expect to see a result relatively close to the mean of 55. If we see an unlikely result, it calls our null hypothesis into question. As such, if we use our results from our sampling to weigh the evidence in the null, simply put, the farther our sample is from the mean, the stronger our evidence is against the null. Okay? And then they give you a thing saying, hey, what would happen if we had like a $54.80, I think that's what they said, or $54.50. Okay? $54.50 is not far away from our mean. Okay? Our standard deviation is pretty broad on this. It's $8. So that looks like we found something within our confidence interval, even though we haven't set it up yet. Okay? But let's say we came to another bill, and another bill came out to $45.75. So $45.75. Well, that's obviously much further to the left. So that might be some evidence saying that we might have been off in our case. Okay? So that's the first part of us looking at it. If we go on to the next page, on page 35, it says we have a candidate running for an election, and they're saying they are at 50. Our alternative is they're saying that they want to be greater than 50. So if you have a candidate and there's only 2 people running, if they are above 50%, hopefully their polls are showing that they would win the election. Okay? So you could do the less than or equal to 50 as well if you were trying to do the other way. So create a null hypothesis. So we're saying that 0.50 is our mean, and our standard deviation is 0.025. It's our standard deviation. So we made our normal curve. Woo! So we could go 50. We go 52.5, 55, 57.5. We could go this way. That would be 47.5. These are all percents rather than decimals. 45 and 42.5. Okay, so that's basically our sampling distribution. If a random sample produces a 52.7, so if we had a 52.7%, this candidate's pretty happy. Their sample is very much to the right. It's satisfying what they are hoping to look for. If they said they were 57.5, so 57.5 is here, that's even further away, further to the right. So in that case, if a random sample produced 57.2, actually 57.2, that should have been. This is very far from the mean, strong evidence against the null. So it's strong evidence against this. And then we will finally start looking at using the p-value, so we can use the p-value to fail to reject the null hypothesis based on this p-value. Okay, so just a reminder that the standard error is the standard deviation over the square root of the sample size. If I had the standard error as probability, it would be the probability minus the complement of the probability over the sample size. So these might go into play. Okay? So that would mean you're going to get a lot of time to work on page 103, 104. So if you get this done, or if you wanted to take a look, I will have the answers to this open on my book up here in this blue folder on top. If you want to double check your work, you can. But that's all I have for you for today. So we will have a quiz next week. I would say it'd probably be Tuesday. I got to double check when the quiz is, but that's what I got. Yeah. Everyone good?